Thank you very much for the kind introduction. Hello, everyone. Okay, here it is. Okay, let's speed up a little bit, okay? We talk about space exploration, great. Moon and Mars, fantastic. But when I grew up as a kid, I watched Star Trek. And that's exploration for me, right? I want to go out to the stars, okay? So is this always going to be science fiction or is it going to become a science fact? How far away are we from this type of technologies? If we look at literature examples, for example, there's a movie saying that what if we would have a black hole in our solar system to do some wormhole travel? Unfortunately, there is no black hole, right? Or what about the warp drive in Star Trek? Is this something that we can build? Well, there are some fundamental limits, as we have learned in university, and I will list the three most important limits for us. So first of all, if we want to get to the next star, it's obviously the distance. It's pretty far away, right? Second thing is it takes a lot of time, so that's the second thing. And then, actually, we would like to bring something with us, so spacecraft or something like this. So those are the three fundamental limits for interstellar space travel, the ultimate dream of space propulsion, okay? The surprising thing is, 2 out of those 3 limits we can do right now. Just the 3 of them together, that's the problem, okay? Let's have a deeper look. So what kind of distance are we talking about, yeah? So what about, I mean, maybe we want to go to 550 AU, so that's a sun focal point. Maybe we want to build some huge telescopes to map really planets outside in other star systems. Or we want to go to the very next star. We already know there's an exoplanet. Not so sure if there's really life out there or whatever, but I mean, it's the next star, so that's an interesting stop anyway. Too bad that we have not been born at the TRAPPIST-1 system. It's just 40 light years away. There are 4 planets in the habitable zone. It would be fantastic to have from planet to planet, right? Yeah, so, okay, well, that's a distance. What about time? What time are we talking about? Maybe I apply for some funding with ESA, then maybe something like 4 years of a project time, right, to realize this stuff? What about the human productive life cycle? So you graduate from university, I grab you, put you on a spacecraft, okay? I send you to the next star, and I promise to you get prime time when you arrive there, and you send us a nice video message, okay? That's something, or we can say, okay, as long as it takes. I don't care, okay? So that's another option. And the third thing is, what are we going to bring there? Well, obviously, 0 payload is one possibility, right? We just get there, no way of transmitting anything back because we have no payload. Or we take at least some sensors, right? So let's take a picture. Let's have a radio to tell us that we have arrived. Or we take something like the space shuttle or Starship. So that's the coolest option, right? So from an explorer point of view. Okay, so those are the 3 fundamental limits. And as I said, 2 of them we can do, okay? So for example, let's do distance and mass. That would be Voyager, okay? So that has been sent off in the 1970s, and it entered interstellar space in 2012, okay? And with a speed right now of something like around about 20 kilometers per second, that's 0.005% of the speed of light, so not very fast. And it will reach, let's say, Proxima Centauri in 18,000 years, okay? So we can do distance and mass, but not time, yeah? So just for us, I mean, when we get somewhere, so we're new, of course we would like to bring a present, okay? Our present here was a golden record, okay? Nowadays we would bring maybe a USB stick, but here this is a long playing record. And do you know what, if the aliens managed to turn the turntable that we also sent, what they will listen to an Austrian speaking English, like myself, okay? Because at that time, the Director General of the United Nations was from Austria. Okay, so, funny side story. Second thing, what about doing time and distance? And we don't care about payload, so absolutely 0. So we already heard about solar sails. Let's take it to the extreme. Let's take the lightest material there is, that's aerographite, okay? It's the lightest material there is. Let's make it super thin, maybe 1 micron. And let's deploy it, close to the sun, a nice big sphere. We don't care about steering, just a big sphere, and off it goes. We can manage probably, if we're a little bit lucky, we can get to the next star in 100 years, something like that. So we can say we can manage time, and maybe we can do distance, but actually, that's, if you think about what was the first type of communication that we had as humans, we sent smoke signals, right? That's a smoke signal, okay? So we send a huge sphere of graphite somewhere else, hoping that someone else will realize, hey, that's not a natural object, and maybe they will send a message back. So that's kind of starting interstellar communication. Okay, I'm trying to experiment with this right now. Let's take it one step further. Let's say, okay, just a tiny bit of payload, please. Is this possible? People are thinking about this too. So that's breakthrough starshot. Yeah, a billionaire was nice enough to give some spare money for this idea. And the idea is to build again a kind of a light sail, to take a payload in the form of a chip. It's called a star chip. There is a little solar array, some radio, some onboard computer, everything miniaturized to a chip. And we send this chip just to the next star. How do we do this? Well, we just ride on a very fancy laser beam, okay? This laser beam, they say they do it with 100 gigawatts, so that's 100 nuclear power plants together. You know, it's a nice cable, okay, you need for that. They told me that probably this is the most difficult thing to bring that much power, you know, on one spot together. And then you need this 100 gigawatts for 8 minutes. And for 8 minutes, you shoot with this laser onto the solar sail, and then you will accelerate to 20% the speed of light. So in 20 years, you're there, okay? Well, I mean, there are some challenges. For example, I can tell you that if a 100 gigawatt laser beam and you fire on a nice shiny sail, it's gone, okay? Not necessarily to the next star, but it's gone. So there are some side applications here, yeah? So anyway, so this is kind of a project that it's at least, I mean, I also had the head of this project giving a seminar talk at my university, and also he agreed, he said, well, this is the best idea they came up with. If I got a better idea, no problem to change, but at least that's what I like, kind of American stuff, they just go somewhere in one direction that kind of makes sense. Well, what about our ultimate stuff? Let's go there with, let's say, the space shuttle, okay? We go to the next star. We go in 50 years so that we're still alive. It's a one-way trip, so we don't go back. And let's take at least the space shuttle, okay? I checked. Half of the cargo bay is enough, you know, for 50 years of student food. Yes, canned ravioli and so on, okay? So it's about half of the size of the space shuttle. I survived for 5 years. Let's stretch it a little bit out to 50 years, okay? 50 years of canned food, and the rest is for oxygen and a few books. It's possible. So, space shuttle, 50 years, next star, one-way trip. All right, what kind of propulsion system are we now talking about? Let's take the best. Let's take the very best. Let's take E's mc square. Cannot get better than that, right? So, we take a little small nuclear bomb, drop it behind our spacecraft and push, okay? You will say, hey, this guy is really nuts. I can tell you that. You can get really small nuclear weapons. They have a so-called fireball radius, where everything is kind of gone, of around only 10 meters, okay? So when you drop your nuclear bomb and you explode it 10 meters away, and you have a nice pusher plate made out of tungsten, you can survive this blast. And this is basically as good as it gets, right? How many nuclear bombs do you need to make that trip? It's the mass of the sun. Okay, so, hey, that really tells something, right? So we definitely need a breakthrough here. We have to reinvent the wheel. We need to do something completely different. And now comes the good thing. Still many things to learn. We checked the universe, and apparently, so when I was young and I was looking upside, and everyone told me that's the universe. Now I know, hey, when I look up, it's just 4%. The rest is totally unknown. There are things like dark energy, dark matter, and in fact, let's be honest, I just read a very nice book about it. They say, let's just call it what it is. We have no idea. And that's great, right? So lots of things to discover, lots of things that we may use to make this trick happen. And it's just a trick, right? That must be our mindset, not, hey, this is impossible. Impossible just means that it's not possible now. People are saying that the person with the most brilliant mind was Leonardo da Vinci. If I would have shown Leonardo da Vinci my smartphone, no way that they would figure out what this is, right? So it's just a trick. That must be our mindset, okay? It's just a trick. So let me just give you two ideas how you could think about making that happen. It's not saying that it will work like that, but let's just be a little bit creative. ChatGPT, okay? In the creativity mode. So let's talk about idea number one, negative matter propulsion. I start with something that you can all very well imagine because it's actually something that you have all in front of you. Positive matter, okay? Positive matter, you start to push it and it will accelerate in the same direction as you push. Everyday experience, F is m times a, no big deal. Now I do the magic trick, David Copperfield, okay? So I invent something magic, it's called negative inertia, okay? So, and how do I know that it's negative inertia? Very simple. I push it and it actually comes to me. Interesting, haven't seen it around, but nevertheless, let's say, what if there's also F is minus m times a? Would this mean anything? It would. We could make something like a dipole, one positive, one negative. We charge it up, and the positive one is accelerated to the right, and the negative one, right? So we push it to the left, but it also accelerates to the right. So we have a self-acceleration system. Perfect. No energy, no propellant. It's self-accelerating. That's exactly what I was looking for, right? So this is kind of the super propulsion system, and probably, I can discuss with some of you in the break, it can even mean that we can achieve with that speed higher than the speed of light. We just need this kind of secret sauce, okay? The question is, where do we find it? Do we have to keep digging in the ground or something like this, yeah? Where can we find it? Maybe dark energy is an answer. Once we figure out what dark energy is, maybe we find this kind of secret sauce, okay? It's kind of, if you need some negative energy, you will say, hey, this is impossible. But just imagine the following. Let's say you were born on top of a mountain and it's completely flat, okay? And you were just used to walk around in a kind of a 10-minute walk around all your life. So you will tell also to your kids that actually we live on the ground, right? That's your everyday experience. Until you go so far, or that you start to dig, that you see actually a gradient, okay? So it can also mean that we are here, we think it's all zero all around us, but it can be that we're on a huge plateau and we just don't see it. We don't see this negative world because there is no really mean to dig or whatever. Yeah? All in a very small scale. We need to amplify that. It can also be that, for example, antimatter is their answer. So maybe, you know, at CERN, you know, at these particle accelerators, they're creating antimatter. So the electron has a mirror partner called the positron. Richard Feynman, a very important physicist, he said, antimatter is like normal matter going backwards in time. Isn't that interesting? Okay, so for example, an electron, you make a movie, the electron is attracted to a positive charge. And you run back the movie and you see, hey, it can also be that it has a reverse charge, but it can also be the electron just running backwards in time. What about gravity? So, you know, normal matter is falling down. What about antimatter? Is antimatter also falling down? They just check this at CERN right now. Just to, you know, try to imagine if they really find, I mean, most physicists will kill me, but if they really find that antimatter has negative inertial properties, forget everything else, stop working, you can build a warp drive right now, okay? It may be just around the corner, okay? So, yeah, just some ideas. The second idea I just want to expose to you, dark matter. Yeah, so there's much more dark matter out there than normal matter. Trick, what if we find out a trick of how to interact with dark matter? We can make a dark matter propeller, and we can, you know, there's lots of propellant out there, for instance. Idea number 2, okay? Well, the good thing is I got you covered, so I'm trying to investigate this for real, okay? So in case you want to do some research on that, or if you want to check out some papers that I'm doing, you can check this out. Okay, so time is short, I know, so I will come to my last slide. The thing is, I just want to trigger your mind. There are lots of possibilities, okay? If every time someone tells you this is impossible, that's a great research topic usually, okay? And usually, also what I'm always saying also to my students, a good engineer always has a plan B, okay? So if no matter what you do, You always have a plan B in your pocket in case something doesn't work. You just pull up, okay, there's plan B. So here we also need a plan B. What if dark matter, whatever, doesn't work out? We need a plan B. And there is a plan B. I told you, 3 limits. We have to eliminate one of them. And it's a very obvious choice. I still want to go to the next star. I cannot kill this, okay? And I want to bring something there, right? The only thing I can kill is time. And actually, we are about to kill this right now. I told you about ChatGPT. What about ChatGPT 10.0, okay? So intelligence is maybe evolving, okay? And it's maybe not limited to our biological time. So maybe it's our destiny to send something like GPT-10 to the stars, okay? So maybe that's the trick, okay? But I'm a sportsman, okay? So the question is not if we go to the next star, the question is who is going to be first, okay? Okay, so the Borg or us, okay? That's it. Thank you very much.